Okay, geometry 5-3, inequalities in one triangle. So I'm going to look at a triangle right here, and I've extended that triangle to get an exterior angle. And so a long time ago, we learned an exterior angle theorem that said angle 4 is equal to angle 2 plus angle 3. So now, making an inequality, I know that angle 2 is less than angle 4. I also know that angle 3 is less than angle 4 because I have to add 2 and 3 together to get it, so they have to be smaller. I can rewrite that a different way. I could say angle 4 has to be greater than angle 2, and also angle 4 has to be greater than angle 3. So those are just some different inequalities that I could write from that triangle. You'll have some examples where it will give you either an exterior angle or an interior angle, and it'll want you to list some other angles in the triangle that are greater than or less than, and you'll see those on the work today in class. Okay, so there's some inequalities. Now let's look at something different. Let's say I have a triangle. Let's go with this one. And I'm going to label this with letters. And this is a right triangle, so I'm going to put my little right triangle box there. And let's make up something. Let's say this is 3 feet, and this is 7 feet, and then BC we don't know. We know what one of the angles is, and we know that it's 90 degrees. If I ask you to label the angles, excuse me, I've still got a little head cold here. Label the angles from least to greatest. Could you do it? Okay. To do that, we need to know what the sides are. All right. This is a right triangle, so I know that BC is the hypotenuse. I know that it's the longest side. Okay, so I don't know the actual value, but I know that BC is greater than 7 feet. So it's the longest side. So here's the rule. The biggest angle is opposite or diagonal from the biggest side. So I go from biggest side, and I'm going to do this color-coded. This is my biggest side. So I'm going to draw a diagonal to the opposite angle. That means angle A has to be the biggest angle. So going from least to greatest, angle A will be in the third position because it's the greatest one. So let's go ahead. I should have done it from smallest to biggest anyways, but that's okay. Let's go a different color. Let's go green. And I'm going to go the middle one. And so here's my middle length line. And if I draw diagonally, that's going to be angle B. So angle B is the middle angle. It's not asking for the actual values, it's just asking for their sizes. Now, obviously, we know which one the smallest one is going to be because it's the only one left, but I still want to do it like I've done the others. This is the smallest side, so I go diagonal, and that makes angle C the smallest angle. Okay? That also works if you know the angles. Oh, excuse me, having trouble talking today with my stuffy nose. It also works if you know the angles on the inside, you can find the sides. from least to greatest. So let's look at one of those real quick. Well, I don't want to do one of those because I still want to go back. I want to do one of these. Okay, let's go with that. Let's call that ABC again. And I'm going to say this is 110. I'm going to say this is 40, which means this one has to be, let's see, that's 150. This one has to be 30. So now I want you to list the sides from least to greatest. So I'm going to find the smallest angle right away. I'm going to do this one correctly and do it in order. Find the smallest angle. There's the smallest angle. So I'm going to go diagonally. Okay, that makes this the smallest side. Oop, where'd it go? Okay, so AC is the smallest side. Then I go to the second angle, which is 40. And I go opposite. And so that makes AB the middle side. Again, we can see which one's going to be the longest side, but I do still want a color coordinate. I'm going to bring Mr. Purple in there. Draw that opposite. So that means BC is the greatest side. Now watch the wording. They might say least to greatest. They might say greatest to least. Be very careful on the wording. So that's Chapter 5, Section 3, Inequalities in One Triangle.